What is going on, guys? This is RMA here with another RMA Fire tutorial. This is the first of my premium series of tutorials where I'm spending a little bit more time and love and sharing some projects that I think you guys are really gonna enjoy. So without further ado, let's jump in and have a look at what we're gonna be learning. You will find this setup already good to go for you guys. Okay. At the end of the tutorial, I'll show you, but literally what we're gonna do for the tutorial, we're gonna duplicate this and we're gonna go every single step of the way on how I built this and how this is done. Okay. So the first thing, we're gonna go into the main build, and this is where you're gonna find everything for the simulation. Okay. The first thing, we're gonna go to the top and we're gonna look at what's happening here. We have a photonic object. We could maybe type other objects so that we're only looking at this scene. And this is the object that I chose for the tutorial. Why? Because in the tutorial we're going to be doing, as you guys know, an interesting shape. And this interesting shape, we wanted to have liquid on its surfaces. It can literally be whatever shape. So I'm deleting everything but one face, and then I'm transforming it to place it in the zero space. So that's like totally flat right here. Okay. If we were to do that from scratch, which is kind of like the workflow for this tutorial, we would select this, we would press P so that you have the information here, and then you come here and then you select one of them, you delete that, this, do delete non-selected, and then we do a transform, and then on the transform, move centric to origin, and then we're gonna get it pretty close to what we had on in here. If you hit spacebar and then the number 2, you will see that it changes as spacebar 3 to get it pretty close to what we're looking for. And now that it's not perfect, but it's relatively close, what I will do is that I like to add another transform. And this transform, we can scale it down here so that it flattens it. You'll see it's now completely flat. We have it to a 1. There is like little imperfections, but if we do flatten, then it's flat. And then if we look at spacebar number 2, you just want to center it here. Now it's pretty good. And then I like to add one more transform so that our pivot is like pretty nice and centered. Okay, so that's our first step. Then what I'm doing here is creating our collider with a extrude, then extrude inward, and then one more extrusion. What does that mean? Well, let's check it out. Let's do it together. We come here, we do an extrude polygon, extrude poly. And we are going on, you can either pull it up here or you can pull it here on the distance and see how it is hollow. So we want to say output back. Now that we've output back, we come back here and if we hit Q, oh, that didn't work. All right, we select this and we hit Q. It's going to create the same node that we did before, and on this one we want to do a little bit of an inset, right? And then we're going to hit Q again, and then we're going to push it in. So this way we have the base of the collider. And then the next thing you want to do is delete that. We hit blast, and we do blast non-selected because we want to isolate this piece. Okay, I'm going to delete this, and I'm going to delete this. And I'm going to repeat that in case, for example, you're here, you click somewhere else, you're like, fuck man, how do I get back to this one? Well, simple. You click here, because if you don't click here, it's gonna select both this and the back piece. We want to select here only the visible pieces, and then we do delete. On the delete, we do delete non-selected so that it isolates only that piece. Okay, very simple, very straightforward, but what does that give us? That gives us our collider. This is gonna be our collider. And then when we isolate this, this is our base for the source that we are extruding, and we're getting basically this. So if we were to, okay, what is that? That is our source. What does it mean? It means that if we click here and I just like do a quick sketch, I'll show you guys that this area right here, if you make it thicker, like that's gonna be filled with water. It's gonna be our water. And then this other area here, from here to here, this is the height of our collider. So the water is gonna be hitting here. We make this really high, the water is never gonna go out. So we're in a decent place. So like this right here will be our collider. So with our source, we're gonna go into .NET to have a look at how the water was created. So you can literally just say .NET and create one of these ones if you want to create it from scratch. If not, then we go in here and I'll show you what's happening on this setup. So the first thing we want to do is create a flip and a flip solver. A flip object, and then on our flip object, we want to go into our guides, particles, change it to particles here. And with our initial data, this is where we want to fetch our source. So as you can see, this is the same thing, right? The only difference is that this one has more resolution and it's grabbing this from the build one. I'm not grabbing it. It might be build one. Okay, it's the same thing, and we're gonna increase the resolution. And then we're gonna move this so that we get some jitter in there. So that's our base source. Then we do a flip solver. Connect this to your flip solver and you will see the bounding here is pretty large. So we wanna scale it down. I'm gonna copy the bounding parameters here because I'm being lazy. Paste values, copy this. Paste values. So this is basically just like scaling this down so that this is the only area that we're creating our computations on. Not the cleanest way of doing this, but yeah, you get the idea. We're just creating art here. We just want to create this piece here. And then in here on my flip solver, the only thing that I didn't really change much, and you can go through my parameters here, you'll see that I didn't really change much except for changing this to epic swirly and adding vorticity. Two things. So here we're gonna do epic swirly, and then we're gonna go into our vorticity. Where is my vorticity again? Versions, the particle motion on the vorticity. You can turn this on. This gives it a little bit more of a whirlpooly underneath look. You don't necessarily like need it, but it helps them behave in a cool way. And we're gonna create an ID and an H of the particles just so we have those attributes. Next, we're gonna do a static object, and this is where we're gonna bring our collision object. In our collisions in here, we're gonna do that we want volume-based collisions. on our proxy volume, it's gonna be without the VDV. Let me show you what that is. So right up here, when we have our collision, I created a VDV from particles and I gave it a value here. So let's just recreate this VDV from particles. We connect this here, and this is gonna give us a proxy 0.01 in scale. VDV from polygons. We're gonna go 0.01, and then we connect this here, and then basically what I'm doing is that this is our resolution. We're gonna copy. So I copied that, copied this, the voxel size, and then in here we're gonna do a volume sample by size. Right, same thing as I did here. Volume sample and by size. Okay, I'm gonna visualize what we have, volume sample by size, and then division size. I'm gonna paste my relative reference so that when I change this number, the VDV outside changes the resolution as well. It's basically like this division here, I am linking it to this one here. So when I change it in here, it changes it here outside automatically. Okay. All right. Volume collisions. Boom. And now we need the source, which is our collider, main collider. And one thing that I like to check when I have my collision in here is like turn off the display of the geometry and just have a look at the actual collision. So this is the resolution of what is gonna be the collision. So we make this a 1.1, very low resolution. If we make this a 0.01, it's gonna give us a pretty nice collision geometry. So we're gonna merge this here and catch. This is a catch. You gotta make sure that this is on the left and this is on the center. If they're not, you can switch them here. But you gotta make sure that the collision is on the left. And then we're gonna add some gravity. And then we're gonna come here and we're gonna turn off the collision guide and just display the geometry, because the collision guide makes your simulation relatively heavier. So let's sim this, see what happens. Nothing much, right? Just like the particles are falling down and are just like kind of landing. Okay? So what we're gonna do is we're gonna add some pop axis force. With the pop axis force, it's gonna give us this shape out here. And this shape we're gonna reduce here by changing the radius and changing the height of this. And you can play with the speed and the lift so that it lifts the particles up a little bit. Let's see what that gives us. And we're starting to get some cool motion here. See some cool motion with some cool stuff happening. You can reduce the speed and maybe increase the speed here and play with the suction so that some of them get like pushed in towards the center. You'll see what happens here. A lot of suction. I did it really powerful. But you can see that it's kind of like it creates some sort of fountain. So you can play around with these parameters here quite easily to create some cool looking effects. And then I'm using a drag to like make it feel more druzy. So I pop drag, just makes it feel more oozy. And of course we could play with the viscosity and other attributes here. But the idea here is just to keep it simple. This is a swirling thing that is essentially what you see on the final result. So I'm gonna delete this, and then I'll leave it here, and we're gonna come back, and you're gonna see that of course the resolution that I synced it is much higher. So to extract this from your .NET, you wanna do a .import. On the .import, you can basically just drag your .network, which would be this one, and you wanna do fetch geometry from network, and then this is gonna give you the information inside with all of the fancy attributes, the ID, and the information that we created in here. And then you could basically just select the flip object name, flip object, and just say, okay, just give me the flip object, not the box or anything else. And that's what you want to cache. So we're doing a cache here. I cached all 240 frames to disk, and you will be able to see them here. This is the simulation that I cached, which is pretty high resolution. I hope you guys like it, and we'll be back with more.